Let's solve a limiting reactant problem that asks for the theoretical yield, the limiting and the excess reactants, and the mass of the excess reactant left over at the end of the reaction. The reaction given is the production of urea from ammonia and carbon dioxide. It's an important substance as it is used as a fertilizer in agriculture. We are starting the reaction with 10 grams of ammonia and 20 grams of carbon dioxide. The plan is to separately calculate the amount of urea from 10 grams of ammonia and 20 grams of carbon dioxide. The lesser amount calculated is going to be the theoretical yield. Each conversion is done in 3 steps. Starting with 10 grams of ammonia, mass is converted to moles, then to moles of urea, then to mass of urea. The calculated mass is 17.6 grams of product. The same conversion is done starting with 20 grams of carbon dioxide, resulting in 27.3 grams of urea. The lesser of these amounts is 17.6 grams, which is the theoretical yield. Since the lesser amount is calculated from ammonia, ammonia is the limiting reactant. This makes carbon dioxide the excess reactant. The calculation of the excess reactant remaining is a two-part calculation. First, the amount of excess reactant consumed in the reaction is calculated from the limiting reactant, then it is subtracted from the initial amount. 10 grams of ammonia, which is the limiting reactant, is converted to the mass of the excess reactant consumed, which is 12.9 grams of carbon dioxide. This amount is then subtracted from the initial mass of carbon dioxide to calculate the mass of carbon dioxide that is left unused at the end of the reaction as 7.1 grams.